Hi, I'm Mr. Richmond. This is your Integrated Math 2, Unit 14.4 Lesson Summary. In Unit 14.4, we're going to try to solve systems of equations. You did this back in Math 1. You did this with two lines, two linear equations. We found that the solution to a linear system was where the two lines intersected, because that one intersection point represents all the solutions on both lines, and that one point would be where it works for both. We can take that same philosophy and principle to solve systems of linear and quadratic functions where we have one of each. It'll be where they cross, or two quadratic functions. Again, the answers of solutions would be where they cross. So I'm going to show you how to do it graphically by graphing these two on a coordinate plane and finding where they cross. But just like we could with linear functions, we can also solve them algebraically. The way we solved a linear system was to do substitution. That's the idea of taking, hey, if this is what y equals here and this is what y equals here, they should be the same. So I should be able to replace the y in one equation with the y in another. And I'm going to use that idea to solve these algebraically in addition to graphically. Now I think I'll go ahead and do graphically first. It is a little trickier because you got to graph more, but having both just helps verify the accuracy of what you're doing. So let's start by graphing the linear function, y equals 2x. Okay, y equals 2x, that is slope-intercept form for a linear equation, mx plus b, in which case m was the slope, which is rise over run. So that tells me how to move from point to point on my line. And the b value, the one not attached to the value, is the y-intercept, which is basically the starting point I'm going to start at. And so when it's in this form, I can tell what point to start at and how to rise and run to get the next point. So if the equation is y equals 2x, the y-intercept is 0, which means my starting point can be 0. And I can just do my slope of 2, which would be 2 over 1, which means I can just rise 2 and run 1 from that point. Up 2 over 1, up 2 over 1, up 2 over 1, etc. And I have my line. Now, if you are really lost right now with how to graph a line, if I went too quick there, talk to your teacher or use our Math 1, I think it's Chapter 2 and 3, Integrated Math 1, Unit 2 and 3 lesson videos on how to graph lines. Let's graph the quadratic now. I have x squared minus 6x plus 7. Now, graphing quadratics can be a little more complicated. So I'm going to try to get a little more information. I'm going to try to get the y-intercepts if possible, the x-intercept if possible. The vertex would be a good thing to have. And from there, if I need more, I'll get table of values. So y-intercept, how do we get the y-intercept? Well, that's always the c value. So my y-intercept is 0, 7. I'll start by plotting that. 1, 2, 3, 4, 5, 6, and 7. And x-intercepts. Now, to find that, I'd have to factor it. And so I'd have to see what can multiply to 7, which is just 1 and 7, but add to negative 6. So 1 plus 7 is 8. 1 minus 7 is negative 6, but that won't work. So really, actually, you know what? I can't factor it. So that's not going to help me. I can't find the x-intercepts easy for this. So I skip them. I move on to something like axis symmetry or vertex. How do I find the axis symmetry? I can use the formula negative b over 2a. And a negative b here would be a negative 6 over 2 times 1 is positive 6 over 2, which is 3. So my axis symmetry is 3, which means my vertex is whatever 3 plugged into this equation is. So let's find that. 3 plugged in. 3 squared is 9. 6 times 3 is 18, so 9 minus 18 plus 7. 9 minus 18 is negative 9. Negative 9 plus 7 is negative 2. So I have the center of my graph is at 3, negative 2. And that gives me a good starting point. So I have 1, 2, 3, 1, 2. Here's my vertex. And I can draw my axis symmetry. What I would do from there is just get a few points. I'd plug in points near that axis symmetry. So 2 would be a good number. Let's plug 2 in. 2 squared is 4. 2 times 6 is 12. 4 minus 12 is negative 8. Negative 8 plus 7 is negative 1. Negative 8 plus 7 is negative 1. So I have 2, negative 1. And because I know where the axis symmetry is, I can reflect that point. So I'm starting to get the shape. Let's try 1 to complete the quadratic. Plug 1 in. 1 squared is 1. 1 times 6 is negative 6. 1 minus 6 is negative 5. Negative 5 plus 7 is 2. And 1 comma 2 is the point here. And I can reflect that 2 away the other direction. And my y-intercept is 3 away from the x symmetry. I can plot that 3 away. And I have my full quadratic now. So there are x-intercepts here, but they were decimals, which is why I couldn't find exactly what they were by factoring. And since they weren't perfect, I don't need them for graphing necessarily then. But now I have a visual of the graph, and I can see from my graph that there is an intersection point right here. And so this is potentially a solution to the equation, but there's also going to be one, if I continue to follow this, there's going to be one up here off my graph. So what I could do is extend my graph up. I'm going to have trouble doing that being on a whiteboard, but you at home could extend that out and just kind of keep going. Go up 2 over 1, up 2 over 1, and then plug in the next point on our graph, which would be 1, 2, 3, 4, 5, 6, 7. And see if that is where they end up crossing or not. But here's the nice part about doing it algebraically, is you can see it can get hard on a graph. It gets hard to find where it's going to cross, especially because these graphs can go very high. So why don't we try doing it algebraically to confirm this point, which was 1 comma 2. That should be one of the solutions, hopefully, if we graph right. And it'll help us find this one that I can't get from my graph. So let's give it a shot. How am I going to solve it algebraically? Using substitution. I'm going to do this work in a different color so you don't get it kind of mixed up with my graphing work. So I'm going to take the 2x from one equation, plug it into the other, and rewrite it. So now my equation is 2x equals x squared minus 6x plus 7. The way substitution works is all it does is allow you to combine the equations to make one solvable equation. All you have to do is solve this now. The catch is it's a quadratic equation. It has x squared. The method for solving quadratic equations is to get them set equal to 0. And then once it's set equal to 0, just like we've done in the last couple of chapters, try to factor it. Okay, if it doesn't factor, then you're going to do the quadratic formula. But hopefully this will work. 1 times 7 is 7, and 1 plus 7 is 8. If I make them both negative, then it's factorable. So x minus 1 and x minus 7 set equal to 0 gives me the x values that should work for this equation. X equals 1 and x equals 7. So I have the two x values that work as coordinate points, but what I don't have, what I'm not done with, is the y's. So how do I get the y's? Just like you did back in substitution days. Once you know the x, you plug it into one of the equations and get the y. Which one do you plug it into? Well, whichever one you want. I'd suggest this nice easy one, y equals 2x. So since y equals 2x, I'm going to plug 1 in and see what y value that is. That creates 2. So x equals 1, y equals 2, means one coordinate solution is 1 comma 2. And look, that matched perfectly with where they intercepted on the graph. And for 7, I'm going to do the same thing. Y equals 2 times 7, which is 14. So those two match up and make an intercepting coordinate of 7 comma 14. And if I follow 1, 2, 3, 4, 5, 6, 7 up, that would make sense. 14 seems like a reasonable number that might cross at. Okay? And so these are the solutions to the system. 1 comma 2 and 7 comma 14 is where it intersects the graph. And that's our process. So I would be ready to do it either way come test time, okay? But it just shows you the relationship between the two. And you could do this with a graphing calculator as well, just so you know. Okay? I'm going to go ahead now and erase this so I can do the next problem with you. And it's going to be a similar process, only this time I'm graphing two quadratics. So I'm going to have two U-shaped parabolas hopefully intercepting somewhere. So let's give it a shot. I have y equals 2x squared plus 4x minus 7, and y equals x squared plus 2x plus 1. Let's start by graphing the first quadratic. Okay, the y-intercept for the top quadratic, 0, comma, -7. I can get that from the C value. Okay, let's get the vertex. Okay, the axis of symmetry, this one would be -b, -4 over 2a. 2 times 2 this time, so -4 over 4 is -1. So my vertex is at -1 comma something. I plug that -1 in. -1 squared is 1. So it's 2 times 1. -1 times 4 makes it a -4 and a -7. 2 minus 4 is -2. -2 minus 7 is -9. So there's my vertex. Let's plot that first bit of information. 1 and -9. 1, 2, 3, 4, 5, 6, 7, 8, 9. That's about as low as I can go. And, oh, I'm sorry, -1. -9. And there's my axis of symmetry. And the y-intercept was 0, comma, -7. So 1, 2, 3, 4, 5, 6, and 7. And I can mirror that point, and I have the start of that parabola. At that point now, I could just make a table of values and start to do additional points near that. So I have 0, I'm going to try maybe 1 and 2. Plug 1 in, 1 squared is 1, times 2 is 2, 1 times 4 is +4, 2 plus 4 is 6, 6 minus 7 is -1. So I have the point 1, comma, -1, and its reflected point 2 on the other side. And I can try 2. 2 squared is 4. 2 times 4 is 8. So I get 8 plus 8 is 16. 16 minus 7 is 9. So I have the point 2, comma, 9. And 3 away, I can reflect the other way. And I have a very large and in charge parabola here. Okay, there's my first parabola. Now I graph my second one. I just need to get enough points to get the basic idea. I'm going to do the same information. What's my y-intercept? My y-intercept is going to be the constant value at the end, so it's 0, comma, 1. Okay, I'm going to find the vertex, because that's an important point, by doing -b over 2a. b this time is -2. A is 1, so it's -2 over 2. So the vertex is at -1 for this one as well. And I just have to plug that back in and get the corresponding y value. I'm going to erase that, I no longer need it. -1 squared is 1. 2 times -1 is -2. 1 plus 1 is 2. 2 minus 2 is, looks like 0. So my vertex is at -1, comma, 0. My y-intercept is at 0, comma, 1. And so I can reflect those 2 points. And because this parabola actually is just x squared, I can speed up my graphing. I could do a table. So you at home, if that's what you want to do a table. You have your vertex at -1, 0, and just start trying some more points. But I know that the trick here, and I've showed this before in my videos, it goes right 1, up 1, right 2, up 4, and then right 3 from the vertex and up 9. And so just like that, I've found my intersection points. They're both at a height of 9. Looks like this is my 0, 0. So 1, 2, comma, 9. And here's my 0, 0, -1, -2, -3. And it looks like -4, comma, 9 are my intersection points. Again, with graphing, I always feel a little iffy because it's hard to be exact on a graph, but it looks like I can see where they're crossing. I'm going to double check it via substitution. So same process now. Again, I'll do that in a different color so you can see what that looks like. But I'm just going to substitute one equation for y into the other and rewrite it. So this becomes x squared plus 2x plus 1 equals 2x squared plus 4x minus 7. And again, it's really just a quadratic equation. I just have to get it in standard form, set it equal to 0. I'm going to keep, this stuff's bigger, so I'm going to keep it on that side and just move everything else over to that side with it. That leaves me with 0 on the left side and 1x squared plus 2x minus 8 on the other side. And now you have a much simpler looking quadratic equation because you've combined everything, and you can solve that again using normal solving methods via factoring. 4 and 2 make 8, make it negative 2 and 4, and it would diamond out perfectly. So my factored equation is x minus 2 times x plus 4. Solve for x. X has to equal 2 here to be 0, and x has to equal negative 4 here to be 0. And so far that's matching. Negative 4 and 2 are the appropriate x values. And now it's just a matter of plugging these back in to one of these equations. I'm going to choose the bottom one. It looks a little easier. I'm going to plug it in. Y equals x squared, so 2 squared plus 2 times 2 plus 1. 2 squared is 4, 2 times 2 is 4, and 1 makes 9. So when x is 2, y is 9 for that one. For the other one, I'm going to plug negative 4 in, so y equals negative 4 squared plus 2 times negative 4 plus 1. Negative 4 squared is 16. 2 times negative 4 is negative 8, so that's 16 minus 8 plus 1. 16 minus 8 is 8. 8 plus 1 is 9. And I have the second answer. 2 pairs with 9. So the solution is 2 comma 9. And negative 4 also pairs with 9. So it's negative 4 comma 9. And my algebraic method of solving the system matches the graph. Okay? And so I think most of you are going to find the algebraic way to be a little quicker, a little easier. But it's always nice to have a visual. And so, you know, it's also a good review to graph quadratics, getting you ready for the final exam. Because remember, all of this comes together on the final exams, and you know how to graph quadratics. Overall, it's just really good practice for the whole process. So hopefully that helps you. I wish you the best.